Welcome to School of Civil Engineering. In our previous video, I've shown you that how to analyze for a frame by using concentrated load, and in this video I'll show you that how we'll analyze a frame for uniformly distributed load or uniformly varying load. So let's start, and I'll use our previous model, previous frame for that analysis. First of all, I'll open STAAD Pro, that is our STAAD Pro, and after that I'll go here frame analysis, that is our previous model. Press on it. So that is our previous model. I'll click here for Z plus view, and here after that I'll go here, that is a previous model, and if you're new here you have to watch the previous video to draw that model. And I'll go here, load pattern, load 1. I'll delete that load. After that I'll go add, and after that member load and uniformly distributed load. And here is the most important thing. Is that they have three types of direction. In our previous video, every time we have used gravity direction for Y, X, or sometimes Z, but now we have to use the direction for inclined portion, as we are using the load on our frame. So that's why we'll use for inclined portion. That's why, suppose first of all we'll give a load, and to give a load, suppose we'll give distributed load, to keep load, it's minus to keep load, and for minus to keep load here is the minus to keep load. Now the question is where we will assign that load. We will assign that load in that direction or that direction. So if we want to assign load in that direction, we have to use local Y. If we use local Y, and our load will be from that point to that point. Suppose first point will be 0 and last point will be, what is the distance of that? First of all we have to find out the distance. So from that point to that point is the 5.831 feet. Distance D2 is 5.831, and after that go add, close, and after that click assign, select by using beam cursor, select that beam and assign to selected beam. Assign, yes. Here is the load. So like that way we can add our uniformly distributed load for inclined portion. Now suppose we want to assign that load in downward direction. The uniform load will not assign in inclined direction, it will assign in downward direction. For that we have to go here, edit, and from here we have to select PY. It will work as Y direction. Change that, so see that it's working as downward direction. It's working as all load as downward direction. And if we use that global Y, it will also work as downward direction. And if we use global Y, then it will use for y direction. here you can use global Z, change that. It will work as X direction, the load will work in X direction. So like that way, if also use PX, it will also work as in X direction. So we'll use that global Y, change that, and we'll go for analysis. Run analysis, save. Yes, they have no error. Post processing mode, done. Okay. So here if we go for deflection, beam, post processing for displacement, if we go beam cursor and if we go here, it's showing the displacement like that. Here is the displacement process of that beam, of that frame. So if we go here for reaction, that is the reaction for our frame. This is the reaction. So if we click on beam cursor, click on it, you will see the loading, and here is the shear. And if we click here for shear, you will see that this is for shear. And if we select for MZ, this is for MZ. And in this way we are able to use our model for analysis. And I will go for modeling, I'll go load page, and here I delete that load. Now I will delete that, remove reaction. Now I will add uniformly varying load. Here member load, here linear varying load. So for that we have to use that option. Suppose for first point it's 1 and for last point it's 2 or 3, and it should be local Y. Add, close that. From here add, select that option, add, assign. Okay, sorry, we have to leave that value in negative and negative for opposite direction. Okay, close. It's showing the load like that way. Then you'll be able to analyze it. And if you also can do that in another way, I can add member load here, trapezoidal load. For trapezoidal load, suppose in our video you have seen that the distance is 5.3831. now we'll consider that we'll give load at we'll start our load from 1 feet distance, at we'll end that in distance 3, and our first point load will be 2 and our last point load will be 4, and it will be global y-axis, according to global y-axis. So add and another load will use our distance will be 0 and our last distance will be 4, and our load will be 4 to 0. It also will be global local y-axis. Add, change. So for fast load I'll select that, I'll use the fast load, assign. So I select, assign, yes. sorry, we have used that value. The positive, we have to give that value. Negative also, it's negative. Change, close. You are showing that this value are working like that way. Now we'll go for that again. It should be minus, change, close that, and for that select that beam, select that, assign to selected beam, assign, yes, you are seeing that our first point was 0 and our last point was 4 from 0 to 4 feet distance. 0 to 4 feet distance. In that way we can provide our load for analysis. For analysis we can provide our load in that way. So I hope it is clear to you that how will work for your frame and how will provide load on it. So thank you very much, and our next tutorial I will go for design section. So stay connected till next video.